All right, for this particular unit, we're beginning a rational unit. Now, if you remember, rational is the R word for the F word of a fraction. Rational just means, remember, a rational number can be expressed as a fraction, and that's the definition. So basically, rationals are just advanced work with fractions. And really what you're going to be doing is polynomials, fractions with polynomials. So factoring is going to be big. There's a couple big ideas here, okay? First of all, the first big idea is that you cannot, or it's not like a big idea like, how would I say it? It's something you need to remember, okay? You cannot have 0 in the denominator. And since you can't have 0 in the denominator, we have what we have called domain restrictions. And for that, basically you set the denominator equal to 0 and solve for the variable, I guess. And that shows you that is the restriction. So for example, take a look. It says find all excluded values for the expression. Okay, that is find all values of y for which the expression is undefined. So we have 3y minus 7 on the top. We're doing nothing with that because there's nothing we can do with that. It's just having us look at the bottom, y plus 10. So you look at it and you go, oh, wait, what could y, I don't actually need to write that. I don't know why I rewrote that. Oh, I can't fix it. Never mind. Hang on. Let me go ahead and lock everything down. Lock all. Okay, and I don't think I can erase this. Pretty sure I can't. Nope. Okay, it doesn't matter. Basically, what you're going to do is you're going to take this denominator and you're going to set it equal to 0. And then if you solve, you get y is equal to negative 10. In other words, negative 10 plus 10 underneath here will give you 3y minus 7 over 0, and that's not okay. That makes this undefined, okay? So the answer is negative 10. It is that simple, okay? For when they're looking for restrictions, just set the denominator equal to 0. Okay, so take a look at this one, and I'm not sure why it's positioned here, but let's put it back up there. All right, it says find all excluded values for the expression, okay, where it's undefined. So again, all you do is take the denominator, y squared minus 81 is equal to 0. Y squared is equal to 81. Y is equal to plus or minus 9 if we take the square root of both sides. Okay, I actually like this way better. It's a quadratic. It's a difference of 2 squares. So you could go y minus 9, y plus 9. So y is equal to 9 or negative 9. Still the same answers. Okay, so you could either put it that way. Okay, that way. Could solve it either way. All right, that's how you solve radicals. And that's it. Okay, 9 or negative 9. You plug it back in, you will get a 0 on the denominator. We don't want that. Okay, solving, evaluating a rational function. Okay, so now you're just plugging in values. So it says h of 4. That just means instead of the x, we put in a 4. So I highly recommend you put parentheses, even if it's a positive, just to build that habit. Truth is, it doesn't matter if it's a positive. You won't make mistakes because the signage doesn't get screwed up. You know how it is with negatives. 4 squared is 16 plus 28 minus 18. And this one is 16 minus 32 plus 7. And then that becomes 16 plus 28. Actually, I'm going to do this. 16 minus 18 is negative 2. Negative 2 plus 28 is 26. And then 16 plus 7 is 23. And 32 minus 23 is, sorry, I don't know why that was hard. It was 9. Okay, so -9. All right, that's just adding. See if you can reduce it any further. And it doesn't look like we can. So I'm going to say that is equal to negative 26 over 9. And that's your answer. Okay. Oh, we were finding h of 4. For a second there, I was like, why didn't we have two values? Okay, I got it. Okay, domain of a rational function. Excluded values. It's basically the exact same thing we just did, except for now they're just saying find all values of x that are not in the domain. They're using the fancy word of domain. What can x not be? Set the denominator equal to 0. Difference of two squares, x minus 7, x plus 7, x is equal to 7 or negative 7. Or you could do x squared minus 49 equals 0. X squared is equal to 49. Take the square root of both sides. And remember, there are two square roots. Okay. All right. That's it. So the domain is what can x be? Always remember that. Okay. Domain is what can we plug in? All right. We can't plug in the 7 or negative 7 because it's going to give us a 0. Okay. Let's try the next one. Simplifying a ratio of factored polynomials. Okay, this is my favorite thing. Honestly, I think this might be one of my favorite things in math. Okay, I love canceling. So what they have done for you is they have factored this out. They put it in factored form. They're baby stepping you into this. This is what you're going to be doing in a minute all by yourself. All right, but you can see that 3b plus 5 is the same thing as 3b plus 5. So these actually cancel out. Yes, you can cancel out a whole binomial if it's the exact same thing. V minus 3 cancels out. Okay. I would prefer you not do this notation. You guys, I don't want to see this. I don't want to see that. Crossing it out that way. Cross it out one direction. It's just what we do. Okay. Don't be all like crazy, like marking things. Just cross it out slanted. Okay. And then 7 goes into 7 one time and 7 goes into 28 4 times. So the answer is 1/4. And that's it. It says you may leave the numerator and denominator in factored form. Well, they all reduced. Let's try another one. Okay. I didn't do a whole lot of that one, by the way, simply because I know you guys are going to get a lot of examples of how we're going to factor it. And I don't want it to be like, I just don't want to do a ton of useless examples when we're basically covering it by doing these. Okay, so it says simplify. Okay, so you look at this and you're like, okay, do you see these plus signs? That means this is one number. 4x plus 16 is one number. Think of it that way, because if I knew what x was, I could plug x in and then I would get one number. Get it? Okay, you cannot cancel pieces. Cannot cancel pieces of numbers. For example, 2x plus 3 over 2x minus 1. You might be tempted to cancel this out. Okay, but let's pick an example. Let's show you why that isn't going to happen. Let's pick, well, first of all, let's pretend you could cancel it out. You would get negative 3 over 1. You'd get 3 over negative 1, which would be negative 3 over 1, basically negative 3. All right, if we could cancel. Okay, but now let's try it and plug something in. Okay, let's plug in a number for x. Let's just do x is equal to 2. So we go 4 plus 3, because 2 times 2 is 4, over 4 minus 1, and we get 7 over 3. And that is the correct answer. So you can see that these two are not equal to each other. So this is an illegal move. Don't do it. don't do this. I actually recommend that you write this as an example of what not to do and put it in your notes. Okay, because don't be tempted. Just don't do it. It has to match. The binomials must match. So the way we do it is we have to factor. So you go, what's in common? Okay, what's in common here? A 4. So you factor out a 4, x plus 4. You're going to get really good at factoring. 7x is common in the denominator, so I get x plus 4. Oh, look at that. See, 7 times 4 is 28x, right? And look, it cancels. So your answer is 4 over 7x. And now it's done. Next. Okay, take a look. Again, it's simplifying. Okay, now here, there's nothing you could do on the top. There's no like terms, there's no quadratic, but on the bottom, there's a quadratic. So the question is, can I factor it? Okay, and let me go ahead. Wait, let me go ahead and get rid of that. Okay, can I factor it? Yes, you can. Y and y. Okay, 6 times 6, negative and negative will get you a negative 12. This is a perfect square trinomial. Y minus 6, y minus 6. And look, this is the biggest thing that confuses kids. If these cancel, you are left with a 1 on top. Y minus 6 goes into y minus 6 one time. Y minus 6 goes into y minus 6 one time. So the answer is 1 over y minus 6. Okay, next. Okay, now you have a more complicated problem. You have a quadratic on the top and the bottom. Again, don't be tempted to start canceling pieces of it. You can't. If there are pluses and minuses, you cannot cancel unless they are exactly the same. Okay, so we're going to go ahead and see if we can factor this. First question in factoring is what is in common. You will have trouble with the numerator if you don't answer that question first. And 2 is in common. So come on. So we're going to factor out the 2 first. So we're going to go x squared plus 3x minus 18. All over. On the bottom, there is nothing in common, but it is quadratic, so we have to ask the question, can we factor it? So the factors of 24, 1 times 24, 2 times 12, 12. How can we get to 2? 3 times 8, that's 5, or 11, 4 times 6. There we go, right there. We can get a positive 2 with a positive 6 and a negative 4. So plus 6 minus 4. All right, but we still need to keep factoring the numerator. So it is quadratic, and they're going to give you factorable stuff, you guys. X and X. Okay, what are the factors of 18 that could get to 3? 6 times 3 is 18. Positive 6, negative 3 will get you to a positive 3. So plus 6 minus 3. All right, all over x plus 6, x minus 4. These cancel. See how they're the same? See how we're multiplying them? There's no addition. There's no addition between these, okay? So these are entire quantities. So our answer is 2 times the quantity x minus 3 over x minus 4. And we can take it out of parentheses because we can, okay? Next. And that was it. Okay.